Oh no! What are you doing? You're going real bud. Freeze! You again. All right, hands up, buddy. You know the drill.
Hi, we're going to discuss how radar works. Imagine an echo. When you clap, the sound wave travels to an object, hits it, and then bounces back. The echo you hear is the sound of your sound wave returning to you. Radar works the same way, except instead of a sound wave, it uses microwaves. Our chip constantly emits the microwaves and listens for their return. Anytime the return frequency changes at all, it trips the sensor and turns the red light on. This system is very sensitive. Yeah, basic. We used a pre-built sensor board. All it required was a 5-volt DC power source, a 200 ohm resistor, and a red light. More sophisticated radar sensors use the Doppler effect to determine the speed of an object. If an object is moving toward the sensor, then the radar wave frequency will increase. When an object is moving away, the frequency decreases. In the real world, you can compare this to the sound of a passing car. In our skit, you saw the robber's various attempts to defeat the radar detector. For his first attempt, he tried to block the sensor's reading with a cloth.
Oh no!
This was unsuccessful.
What are you doing?
Determined as ever, our bandit pushed forward with a harder, more dense material, the whiteboard.
Oh no!
This attempt also
What are
failed.
you doing?
In jail yet again, our bandit picked up his physics book and learned that radar uses electromagnetic waves. Wood and cloth are insulators. The radar passed right through them. To beat this high-tech security system, our bandit needed a conductive material, aluminum. When radar hit the aluminum, it bounced back. Finally, our thief had a way to defeat the radar detector.
Radar system began to take shape at the start of the 20th century, especially as the military need during wartime demand better detection methods. The British scientist Robert Wilson White was the key figure in this development, making a groundbreaking realization that radio wave could be used in detect aircraft. This insight led to the creation of radar system, which played a critical role in World War II by helping detect enemy shape and planes. Following the war, radar technology evolved and expanded into civilian applications such as air traffic control and weather forecasting. Today, radar systems are embedded in every technology, with a card to utilize radar for safety features.
Along the way to the finished version of our project, we had a few failed attempts. Originally, during the testing, we were trying to see if our radar was working properly by waving our hand in front of the sensor. What we hadn't realized is that any movement nearby the sensor would trip it. So even if you just barely moved behind the sensor, that would set it off. We were doing our tests by hand instead of on a platform, so any sort of movement was throwing faulty data. We'd also tried to use an Arduino. The Arduino didn't work properly because we were trying to filter out the data being transmitted from our sensor. What we didn't realize is that our sensor had a distance of 16 to 24 feet. So anything that wasn't in this field was giving us faulty data. Ultimately, after learning everything about our radar sensor, we were able to set up a proper test stand and get the results that we wanted. While radar technology has been around for a while, there still is a lot of new applications coming out. One major application in recent years is the phased array radar system. This takes the same concept of a radar and connects lots of them together through a computer automated system. These radars will send out a signal in different locations, and when one returns back a signal, all of the other radars will point towards that location. This allows for a lot faster of a response time, and it also allows for multiple different frequencies to be sent towards the location, getting a wider range of data. This, when it was implemented into the military aircraft, was actually our first sighting of what we think to be a UFO. While they're debating this in court right now, it still is pretty interesting that we didn't see something before this technology, and after implementing this technology, we see what might be a UFO. This might be something interesting to look forward to, or maybe to be scared of, but hopefully it'll turn out good for us. If you have any questions, or if you found something interesting in our report, please ask, and thank you for listening.
Got my radar gun handy here. We're gonna see who we can catch speeding today. He's going down. You're going straight to jail, buddy.
No!